Hi, Dan Kelly here. I've made a little Python script called RPN. It means reverse Polish notation. It's just a little calculator you can use in the command line on a Unix system. I'm on a Mac Unix system. Um, I have it aliased to comma RPN, and if you just run it, you get that. To get some help, you do that. So I'm going to walk through the help a little bit here. At the end of the help, it says where you can get it. And if you wanted to alias it, like I say, I alias it to /bin, comma RPN. Now, I'm going to page through this a little bit. The options that you have are H, D, and S, the long forms as well. I won't maybe get into S. -S will show the stack as it's working on it. And help is help. Okay, so this would be an example. And for me, I would type comma RPN, but RPN space E and then enter, and it will print back out this. This is Euler's number, and put a -D10, and then it will give Euler's number to 10 digits. Pi is in there as well. I think those are the only two built-in constants at the moment. RPN 10, and now I'll just go just try that for an example. Sorry. There's a stack, and if I want to add the two things in the stack, what it does when it sees the plus, it gets the stack, which was 10 and then 20, and it adds the two things together. This would divide them. This would multiply them. No, that won't multiply them. You have to do X to multiply them. Well, why doesn't star work? Because you can see that well, I won't bother with that. Star will expand all the file names. Why am I not bothering? Because I'm in a directory that has hundreds and hundreds of files, so I won't bother with that. So that's fine. Go back into this again. There's some sort of other stack operator. I've just shown you plus and minus, and these are in there as well. There's another one called exchange. If it was 10 and 35, the result then would be 35 and 10. That can be useful sometimes. Um, Sine and cosine and tangent, etc. They're done in degrees. So 45 sine will give you 0.707. And arcsine is using degrees as well. ln is natural log. Log is base 10 logarithm. The caret operator, this little upward pointing arrow, that means exponentiation. So this is the stack has on it 10 and 2. It sees the operator exponentiation. It will give you 100 for that. Now, the next ones are a little bit subtle. 0.5, 0.3 minus, that should be 0.2, shouldn't it? And then 0.3, 0.1 minus, well, that should be 0.2. But if you run it, you'll find something like this. It might not be exactly like this. I'm on a 64-bit ARM machine. So it's 0.2 and almost 0.2, but not quite. So if you want to test for like almost but not quite, you can use the approx operator, and it will answer 1. That means true. You can also use the equal operator, and that'll answer 0 because it's not true. They're not equal. And to see that, you could try this, and I would suggest if you're at all interested in this, just type this stuff. Don't copy and paste it, but type it. Get your fingers used to typing. I don't think you learn anything by copying and pasting into a terminal. So here what I'm doing is I'm subtracting. Oh, goodness, it looks like 0, but I'll turn on a whole lot of digits. So yeah, if you tried those examples, you would basically see the kind of things that you can do. So in the help, if I add new operators, I will document them in the help. So the list that you can get if you do -h might be a little different to this. So the forward sine cos, oh, I could put in like hyperbolic cos and etc. And I use them, so I'll put them in as well. Anyway, this is a normal circular arc cos, arc sine, arc tan. Exponent, that's e to the thing. Ln, that's log base e. Log base 10. Square root, I'll probably add square, SQR as well. CHS means change the sign of the thing. X means take e to the thing. Inverse means take 1 over the thing. These are the consuming binary operators. What I mean is that the stack length gets reduced by 1 every time you use them. Approx and equal, you've just seen, plus, minus, etc., you've seen them as well. This is a non-consuming binary operator. It exchanges the two things, and that's how you install. All right, so that's it basically. Um, might be useful for you. Maybe I'll quickly uh, show you the code. There's like, it's not really very long, 150 lines of code. And most of it is just this. Like when I said that I would add in, where's the square root actually? I said that I would add in square. Let me just do that. And so basically, um, I'm not sure. I think I need a float here, so I'll check on that. Yeah, I will check on that. And I think you can do that. Sorry. I think you can do that in Python, but I don't remember. I'll fix that up anyway. But that's how you add new operators. And once I do that, I'll have to go back and put that in the documentation as well. I'm going to mark that spot so I can come back to it later. Most of the code, it's not especially complicated, but it accreted, right? It started with 4 or 5 lines and it accreted. So this is how I do the approximation, if you're interested in that. This is for degrees and radians conversions. This is just checking that the stack has stuff. And here are the examples that you've just seen. So far, where are we at here? We're down 40% into the file, and it's just helper stuff. This is setting up the parser, and now we're 48% of the way in. And here's where it actually begins at this stage, 50%. So 50% is doing the actual computations. And what am I doing? I'm going across all the tokens. Token C is the count of tokens. I'm finding the length of the stack. I need that later on. So I'll just show you here how plus works. So if the token is a plus, it makes sure that there's two things on the stack already, in addition to the token. It doesn't actually put the token, doesn't actually put the plus on the stack. It consumes immediately. And so that's what we do. So we go back to, and we make that be the sum of those two things. And then we get rid of the very last one. Um, how would we do minus the same thing? See, it's pretty simple. You could add stuff if you thought this was useful. At one point, I wrote an RPN called IRPN that worked on images, but then software started coming out like Image Magic and stuff that did that sort of work, and there was really no reason for me to do that anymore. RPN's a cool thing. I know I'm weird to say that, but I like it. Thanks for watching if you watched the whole thing, and take care. Bye.